Yesterday we talked about some examples of situations where normal force affected the force of friction, right? And we talked about how in Canada we often will throw like bags of sand or cinder blocks or hay bales in the back of a pickup truck in the wintertime in order to increase the amount of traction that that truck will have. And that works because when we increase the weight over the back wheels, we increase the normal force pushing against the back wheels, and that affects the force of friction through the formula we have written right here, right? So all we're doing is investigating the relationship between normal force and the force of friction. That relationship should be pretty straightforward. If normal force gets bigger, what happens to friction? It gets bigger. Okay? They're directly or linearly related. Okay? When one goes up, the other will go up. If I double the normal force, I should double the force of friction. Okay? Very, very simple. Now, they are also related through the coefficient of friction. It is something that does affect, okay, the force of friction. Right? If I double the normal force, okay, and mu stays the same, then obviously the force of friction will double. Okay, things like that. So we got to remember that mu is also part of that. Okay, what we want to be able to do in this lab is use the relationship between the force of friction and normal force to calculate the coefficient of friction between these friction sleds and the floor. Right? Now, we're going to do that using a graph, not just manipulating the formula 5 times. I'm going to say that again so that you get it. We are going to find the coefficient of friction from a graph of normal force versus friction, not by manipulating the formula 5 times. Okay? Everybody follow me there? All right. So for our design, for our variables here, okay, the variables involved in this lab are the coefficient of friction, the force of friction, normal force, acceleration due to gravity. Okay, those are really the forces that are involved here. Okay, or the variables, sorry, that are involved here. Now, the way this lab is going to work is that we're going to have these friction sleds placed on the floor, and we're going to attach to them a force sensor. All right, so it's going to work similar. You're going to still be using that SparkView app that we used with the carts, except now you're not using the carts, you're using this force sensor. Okay, so you'll connect to these little AirLink devices instead of the carts. Connect the same way. Okay, so you'll hook on the force sensor onto the sled. Okay, and what we're going to do is change how much mass is in the sled. When we change how much mass is in the sled, before you go writing down that the manipulated variable is the mass of the sled, because that's wrong. Don't write that. It's wrong. Okay? Every time I change the amount of mass in this sled, what am I changing? Okay, system mass, anything that doesn't have to do with mass. When I change the mass of this, it's going to be lighter. Okay? If I make the sled lighter, what happens to the normal force? It goes down. So maybe, since this lab is all about the effect of normal force on the force of friction, maybe I'm manipulating one of those two forces and looking for the response in the other. Subtle, huh? Okay. Okay. So your first trial, okay, your first trial in this lab is just going to be the sled with nothing in it. Okay. Now the mass of these sleds, when they're empty, are 0.254 kilograms. Okay, each and every one of them. Right. So the mass of the sled when empty is 0.254 kilograms. So your first trial, empty sled. Second trial, you're going to put the first two masses onto the sled. Okay, the reason we put the first two on is because, well, then we have less trials and it takes less time, but also because adding this dinky little mass here doesn't do anything. We don't get significantly different data. So, okay, we're going to add two masses. That'll end up being Arms are full. 30 grams of mass to the cart. Okay, and then we'll do another trial, and then we'll add another 30 grams to the cart, and then we'll just keep adding the mass. The numbers are written on them. With your young eyes, you won't have any trouble with them. Okay, so we'll just keep adding on until we've got the carts, the sled, full of mass. Okay, everybody follow me there. So each time, what you're going to do is you're going to pull the sled. Now the technique here is important. Okay, when I pull the sled, I want to have the string taut. Okay, and then I just want to increase my pulling force gently until the sled just starts to move. Okay, don't just jerk it. Okay, you want to slowly increase your pulling force until the sled moves. Okay, that's all you have to do for each trial. Your phone will pick up the amount of force read by this sensor. Okay, and it'll go up, and then it'll drop. Okay, when it drops is when you overcome the force of what? Friction. So whatever that maximum number in terms of newtons is, that was the force of friction for that trial. Okay, so you're directly measuring the force of friction with this force meter. Okay, so all you have to do is look for each trial of what the biggest number was, and that'll be your force of friction. Everybody follow? Okay. Sorry, back to variables. I talked about manipulated response. Controlled variables, okay, anything that's going to stay the same that could affect our experiment. And I would say that there's some things that you're going to need to be cognizant of when you're doing this lab. Okay, in terms of controlled variables, we're going to be doing this on the floor because the floor is better than the top of the desk. The desk is too slippery. Okay, we're going to be doing this on the floor. Each time I pull that sled, should I use the same spot? No. And what should I do to the sled each time I pull it? Wipe it off. Yeah. So one member of your group should go should get the paper towel, a little bit of paper towel there off the table. Okay, and you should clean the bottom of the sled and clean the floor that you're going to use each time, because we want it to be consistent or controlled on each trial. Okay, so that we're comparing things fairly. Okay.
Could you say that mu would want to stay the same?
I would want mu to stay the same as I'm trying to calculate it. Yes. Okay. For our hypothesis, okay, if and then statement. Your if part should talk about the relationship between those two forces. Okay, the and part, as always, describes the experiment. Okay, the then part needs to tell me how to calculate mu from your graph. Okay, fairly straightforward. Okay, we're just going to run a few trials where you pull the sled. Okay, then you're going to look at your data. Okay, and you're going to graph your data. So in your data chart, okay, you're going to have something like this. Okay, you'll have the mass. Yours looks like this, right? Okay, so you have the mass. Okay, that'll be the cart plus whatever you put in it. Okay, how do we calculate the normal force? No. No. Oh my God, guys. I'm putting a box on a level surface. Normal force is equal to gravity. Please calculate the force of gravity. That's the normal force. Okay? Sorry. Okay, so that's how we calculate normal force. It actually says that somewhere. But anyway, okay. Then static friction, that's the number that you're getting from your phone, from the app. Okay? You don't need to import any numbers. Basically just look through the data, okay, and find the biggest force for each trial. That will be your force of friction. Write that down for each trial. Okay? And then you're going to build a graph of this versus this. Okay? From that graph, you should be able to calculate mu. And that's all there is to the analysis for this. Okay? You can see here, the analysis is fill in this chart, and then show me a graph of normal force versus friction where you calculated the coefficient of friction. Okay? Then explain why what you think from the graph was mu is mu. Okay? Just a brief explanation. I think that whatever part of the graph was mu is mu because.
Nice.
Everybody follow. I'm going to say this one more time. Do not show me 5 separate calculations of the formula manipulated. I don't want to see that. I want you to calculate mu from the graph. Okay? All right. Then you have your conclusion. Same as always. Copy paste your hypothesis. Explain whether it's right or wrong. Evaluation, sources of error, how to fix them. People have been kind of forgetting the how to fix them part. Okay? Don't forget to put in how you would fix those sources of error. Okay? And then that's it. Are there any questions on what we're doing? Okay, so a group can use this setup here if they want to. Okay? If you got questions while we're working, let me know and I'll help them.
How do you spell mu?
M-U. Mu. Yeah. Okay, let's have a look up here, guys. So when you export your data for what you've just done, right, you should get something like this. You'll get your time, for whatever reason, we don't really need that, okay? And then you're going to get your pulling forces for each trial, okay? All I need to do is go through these numbers and find the biggest one for each trial. So my largest force for trial 1 was 1.14 newtons. Okay, my largest force for trial 2 was 1.37. For trial 3, it was 1.43. Okay, and for my second one, looks like 1.52 was my biggest, and for trial 5, looks like 1.55. All right, so now I've got my maximum forces. I take those numbers and I put them here. Okay, everybody with me on that? Okay, I'll already have my normal force numbers because they're going to be the mass of the sled. So like for the first trial, it was just the sled, so 0.254 kilograms times 9.81. Then I'm going to make a graph of these 2 columns. So I'm going to take these 2 columns, I'm going to put them in Google Sheets, and I'm going to make a scatter plot of that data. All right, everybody follow there. Then you're going to want to get a best fit line, get the equation of that line, okay, and go from there, figuring out how to get mu from that data, from that graph. Okay? Does that make a little more sense now that you have the data?